service in Raleigh. It's Nick Petro with your special briefing here, 9 a.m. Tuesday on the 9th of January here. And so things are still underway with the severe weather episode, tornadoes, flash flooding, non-thunderstorm gusty winds, all possible later today. So let me take you through a couple slides real quick. Let me just, because these kind of highlight the big picture, and then we'll get into the details. But the event highlights with this storm, the main hazards are heavy rain and subsequent, risk for flash flooding, gusty winds, and threat for damaging winds when the storms come through, and perhaps even a few tornadoes. Rainfall 1.5 to 3 inches, highest in the western Piedmont Triad down to Albemarle and Wadesboro. That's where we think the highest rain is going to be. Locally higher amounts in those heavy downpours. And then, of course, that rainfall could lead to scattered flash flooding and subsequent river flooding. Our confidence is pretty high because, we're kind of just watching the radar here, and we're day zero. It's on the way. So if you're in Fayetteville, if you're in Laurinburg, Clinton, Goldsboro, Benson, Dunn, those areas up towards Wilson, those areas all have the highest risk for to see a tornado, of all of across central North Carolina if you compare other parts of the central part of the state. Not to say that places. Now, keep in mind, this isn't just a tornado map. This is an overall severe thunderstorm outlook. So this doesn't address just tornadoes. This also addresses the risk for damaging straight line winds too. And I apologize for folks here indicating the lost audio. Yeah, it looks like we're having some bandwidth issues here. Let me see if I'm seeing some folks saying the audio goes out, it comes back, and so forth. I'm just going to keep going here, and hopefully the bandwidth will allow for consistent audio. Okay, all right. So anyway, the yellow and orange combined, and even the green, still indicates a risk for damaging straight line wind gusts. Okay. I think in terms of what type of severe weather we're going to experience today, I think it's mostly a straight line wind event. But keep in mind, straight line wind events can look like there is tornado damage. There's not much difference between the type of damage you would experience with a 70-mile-per-hour straight line wind gust versus an 85-mile-per-hour gust from a tornado. The only difference is the damage is more circular versus blown out in one direction. But the point is 70-mile-an-hour damage from a straight line thunderstorm gust is not a whole lot different than a low-end tornado. So keep in mind, we need to be concerned about straight line wind gusts, which are covered under severe thunderstorm warnings. So don't just be on the lookout for tornado warnings, and don't disregard severe thunderstorm warnings. Keep in mind that severe thunderstorm warnings should be treated with the same amount of caution as tornado warnings. Make sure you have a way to get those severe thunderstorm warnings. Okay. All right. Hopefully the audio is good there. All right. So what about the non-thunderstorm winds? Well, we have a wind advisory that's in effect basically now through 10 a.m. to 10 p.m. And sustained winds, we're looking at mid-20s to around 30. Highest across the I-95 corridor. When you factor in gusts, and again, these are non-thunderstorm gusts. These are outside of thunderstorms. There could be some gusts around 40, maybe up to 45 along the I-95 corridor. But the bottom line is it's going to just be windy today. So don't be surprised if lawn furniture, trash cans get blown over and there's no thunderstorm around. It's just going to be windy. Now keep in mind, these winds are not terribly strong now because the atmosphere is cool. If you step outside, it's in the mid 40s to around 50. That's cool. Though if you were to go up 1,000 feet above the surface, the winds are howling. It's strong up there. So we need the warmth to be able to transfer some of those higher winds down towards the surface. And that really won't happen until things warm up a little bit later in the afternoon. So that's why I don't think these winds I'm showing right here are going to happen right away this morning. It's more like later today after we get some warmth coming up from the south. Okay. All right, so what about rain, excessive rainfall? Basically, the yellow means that there's going to be some scattered instances of flash flooding. All this highlights is that flash flooding is possible, okay? So, an inch and a half to 3 inches of rain, especially if it comes down all at once, is what generally leads to flash flooding. It's not so much the amounts, but it's the rate. So, if you have 2 inches of rain spread out over 24 hours, that's not going to cause flash flooding. But if you have 2 inches of rain spread out over an hour, that's what's going to cause flash flooding. It's the rate at which it comes down, more so than the amount. Even a half inch of rain can cause flash flooding if it all falls in 5 minutes. So anyway, just keep that in mind, that flash flooding is going to be a concern. Never drive through areas where water covers the roadway. When you add up, an inch and a half to 3 inches of rain, that could eventually lead to river flooding. So the map on the right just shows the river spots that we think, the particular rivers we think have a risk for flooding. Minor flooding is noted in the orange. If there's an orange dot there, the gauge at that location will probably indicate minor river flooding. So we're talking, the Rocky River, Norwood, the Yadkin will probably experience some minor flooding. The Tar River, Rocky Mount. There is maybe near flooding along the Neuse, but it's not really, locked in yet. The Haw River probably is going to experience minor flooding. So that's the takeaway from this slide. Okay, and that usually takes a day or so for that to all evolve. All right, so let me go to the live data real quick here, and let's show what's going on. And this is a big picture, zoomed out view of current radar data. And I apologize, it's taking a moment here to load. Hopefully the bandwidth isn't slowing this down for you, but clearly you could see, and I'm going to get my highlighter out here so you could see. Notice that most of these more intense thunderstorm cells are down, basically from Atlanta southward. Okay, and this purple line here is a tornado watch. Okay, that's a tornado watch. Over us right now, let me add on, let me throw warnings on here, and you can see there's a bunch of severe thunderstorm warnings. The red indicates severe thunderstorm warnings. So clearly these storms to the south from Atlanta southward have a risk for damaging straight line winds. The purple indicates tornado warnings. So obviously there's a bunch of tornado warnings out over the Florida panhandle. So anyway, that's where the severe weather threat is confined. And the reason it's going to take a little while for it to evolve over us is right now, look at these temperatures. The temperatures over us are in the 40s. So versus temperatures in the 60s down ahead of the severe weather over southern Georgia and the Florida panhandle, right? So it's going to take some time to get some of these 60s dew points. If we look at dew points, I want to see at least some, low 50s to around 60 dew points getting up into our area before we really start to see some of those higher winds mixing down and the severe threat. Now, clearly this is a very stable atmosphere over us right now, but the wind is from the south and southeast. So what I want to point out here is these barbs here indicate the wind direction. So the bottom line here is that the winds ahead of this line, and let me stop it here for a moment. Bear with me here for just a second. Let me stop it at the latest one, and let me turn off the winds so we can see a little clearer. And let me get my drawing out here. So clearly the severe threat is confined to this part of the line right now, right? Well, that's because that's where it's the warmest. But out ahead of this line, the winds are from the south and are very strong. So as this whole thing propagates to the northeast, right, so too will these strong southerly winds. So when the line gets, say, over here, those strong southerly winds are going to be right out ahead of it. The bottom line here is what I'm trying to say is, as this line gets closer and closer, these southerly winds will increase. just ahead of the line and pull in the warmer air that we need to result in those strong storms over us. So while it's stable, while the sky is gray, and while it feels really cool, you're probably stepping outside and like, man, it's freezing out here. How are we going to have severe weather? Keep in mind, as this line moves east, so too will the strong winds ahead of it, which will bring in that more warmer and unstable air. That the unstable air, basically the energy, the fuel, if you will, for the storms to produce gusty winds and strong storms. Okay, so just don't be kind of fooled or think, we're out of the woods, right? Because it's cool outside. Okay, so that's what's happening right now. Let me show you some simulations to show you the timing, and then I'll take some questions here. But bear with me here for just a second while I switch. Okay, so this is a radar simulation, and you can see the time at the top. Here's roughly right now. So clearly these are two different models, okay? Because we like to get a range of different solutions. I don't look at just one model and focus on it. I want to look at a variety of models, right? And the answer's somewhere in between that, right? So this particular model, I'm showing this is because this is a faster solution. It's a little more aggressive. It is clearly not raining this hard right now across the Western Piedmont. This model on the right is overdone. But just because it's overdone now doesn't mean it'll be overdone later, okay? So let's just walk through this. This model on the left is actually a little closer to reality and what's happening right now. So let's step through this, and you can see generally the green represents, rain, and the yellows represent heavier rain, okay? So that by noon, these models have a couple different solutions. This model that's a little more aggressive pulls that line eastward and basically starts to move it across the western half of the state near Charlotte region as early as noon, and fairly intense. Whereas the model on the left, which is a little more, probably a little closer to reality, also shows some intensification of these storms as the storms are moving across the South Carolina upstate. Okay, so then let's take it ahead a couple more hours. Let's go to 1 o'clock. You can see the more aggressive model on the right brings storms across western sections of central North Carolina, and quite intense, I might add, by 1 o'clock, whereas this model on the left is a little more reserved, probably makes a little more sense given the fact that it's fairly stable and it's going to take some time as the storms are approaching to draw up that warm air that's needed for intense storms. Okay, so then as we move ahead to say 3 o'clock, by 3 o'clock, the model on the left, which again is a little more reserved model, starts to show a thunderstorm line, a squall line taking shape here in vicinity of approaching the Yadkin Valley. Okay, and that being the case, you'll notice that that it looks fairly intense all the way down through South Carolina. That's because ahead of this line, it's pulling up the warm air that needs to fuel these storms. Okay, so by 4 o'clock, 5 o'clock, you can see these two models are actually starting to come into better alignment. So what this tells me is my confidence is increasing that by 5 p.m.-ish, there'll be a pretty intense line of storms moving across, approaching or moving across the Triad region down towards, excuse me, Richmond County and Rockingham and Carthage and Sanford. So you could see this line taking shape around 5 p.m. And then as we head to 6 p.m., we've got a pretty intense line of storms moving through the Triangle region down toward Fayetteville. And by 7 o'clock, it's crossing the I-95 corridor. By 8 o'clock, it's basically moving into eastern North Carolina. And look how these models generally better match towards the end of the day. They start off different, but they match at the end. So that basically increases our confidence that, number one, the timing is more of a sort of a 4 o'clock to 8 o'clock event from basically the Triangle and US 1 corridor to basically the I-95 corridor. So somewhere between 4 and 8, that's when basically the excuse me, this portion of central North Carolina will be under the gun, 4 to 8. And it could be more like like maybe 1 to 3 for the western portions of central North Carolina. Okay, so that's what we have to do for timing. Now, the storms across the western portion, the earlier storms, probably are not going to be as intense because it's going to take time to get that warm air up from the south. But by the time the storms enter the eastern half of central North Carolina, there will have been time for that warm air to be drawn up from the north. Okay, so that's probably the best way I can convey the timing. And let me back up and go through this one more time. So that by noon, we're starting to see storms take shape across the Yadkin Valley. And keep in mind the simulation on the right, I think, is overdone in terms of intensity. Okay, by 2 o'clock, basically the triad down to Wadesboro is sort of under the gun, so to speak. Storms will probably be picking up in intensity around that time. By 4 o'clock, now the storms are moving towards the Triangle region, down towards Rockingham and the Sandhills region. And that by 6 o'clock, the Raleigh metro area, down toward Clayton, Clinton, Fayetteville are going to be experiencing the storms in the I-95 corridor from basically 7 p.m. eastward. Now, let me also mention that the risk is, as I point out it on this slide. Let me back up real quick. Remember what I said is that all of central North Carolina will have the risk of seeing a damaging wind gust, but I think the risk for tornadoes is highest in the orange area. Okay, so again, if you're from Wilson to Clayton, Sanford to Wadesboro and south, that's the area we think the risk for tornadoes will be the highest. So we're talking basically late afternoon into early evening. Okay, that's the time frame for that area to see storms. Okay, so bear with me for just a second while I take a sip of water. Okay, hopefully that clears my throat. All right, so anyway, there you have it in terms of the timing. One other thing I want to show real quick is just the non-thunderstorm winds. And as we get to basically the current time frame, don't necessarily focus too much on the values. Just know that the deeper yellows and orange represent windier conditions versus the grays represent less windy. And as I step you through midday, you can see how, look how the winds are overall expected to be increasing. Notice how the colors are getting more vibrant as we head through the afternoon. Well, those are the non-thunderstorm winds that I've been talking about. And then, this model is also capturing thunderstorm winds as well, but all of this yellow is highlighting non-thunderstorm wind concerns as well. So when does those colors turn more vibrant? Well, there's 10 a.m., 11 a.m., noon, 12, 1, 2 o'clock. By 1, 2 o'clock, it's going to probably start to feel pretty gusty out there, even outside of thunderstorm activity. So the point I'm trying to make here is that it's going to be getting windier as the afternoon progresses, just windier in general. So keep that in mind. All right. So anyway, that's what I had prepared for you for today's briefing. Now, obviously, this is an evolving situation. Things are going to change. So I'm going to do things a little differently today. I'm going to leave this live webinar up and running pretty much all day today. So this link will remain active. This webinar will remain active. And I'll return at least once every hour at the top of the hour to provide a quick 5-minute update on how things are evolving, just so you have the latest. Because as soon as we end this webinar right now, it'll become, things will change inevitably. Things always change inevitably. So what I'd like to do is keep everybody up to date and provide an update via this method once an hour at the top of every hour. So basically, at this point, I'll take some questions, and then once the questions dry up, then I'll just go on mute, and I'll come back at the top of every hour to provide a quick update. All right. So anyway, let's. Okay. Good morning again, everyone. Nick Petro here, National Weather Service Raleigh. So just with your quick update for those who are just joining, I'm going to be providing an hour every hour on the top of the hour and a quick update just to keep it fresh and make sure you have the latest. A couple housekeeping things first. I am having a couple minor email issues here. So if you sent me an email, I apologize if I haven't gotten back to you. It's we're having some bandwidth, couple bandwidth related issues, and that's also slowing me down from being able to email out the PowerPoint briefings. So so anyway, I will find a solution and get those emailed out within the next 15, 20 minutes, one way or another. And secondly, in order to create a recording, I have to stop the webinar. And so I will actually be closing the webinar after this update, just so the recording is created. And then I will join right back as soon as recording is compiled. And but it's easy for you to join again. Just simply use the same link that you used to initially join. So whatever link you use to make it show up on your screen, double click that at any point in time, and that'll rejoin you. All right, so what's going on with the storms here? Well, what I've got loaded here are live radar. The purple, this squiggly purple line is a tornado watch. The smaller polygons are tornado warnings. The reds are severe thunderstorm warnings. The green are flash flood. This big circle here is the Storm Prediction Center mesoscale discussion. So anyway, remember I talked earlier at 9 o'clock about how it's cool outside. We're waiting for the temperature to climb. Look how the temperatures have climbed. Look how we went from 45, 44 an hour ago. We're already up to 50. Places to our south and east are in the low 50s. It's in the low 60s and climbing along the coast. So clearly we are warming up, and that's happening very quickly. And notice too, this yellow line here, this yellow shaded area, that's dew points, which are a measure of moisture. And basically the higher the moisture content, that helps to make things more, helps to destabilize things. So what we want to see is the higher the dew point, the better, right? So we're watching this yellow, and look how the yellow is creeping northward. And it's also pushing in from offshore as well. So the buoyant air that helps create thunderstorms and drives thunderstorms is indeed quickly lifting to the north and from the southeast as well. And temperatures are also climbing. So you could see now, look earlier, the northern extent of the heavier storms was here. Now the heavier storms is all the way to the north. So as we were mentioned earlier at 9 o'clock, this clearly is evolving. This line of storms will eventually move to the east and northeast, and this is what we'll be dealing with as the afternoon progresses. So everything is still on schedule. No changes really from what we talked about. The main update here at 10 o'clock is I wanted to point out how quickly it's warming. And it's warming most across areas south and east of Raleigh. This is where this area here has the greatest warming, okay? The greatest increase in temperature and the greatest increase in dew points. And that's why the Storm Prediction Center has highlighted, let me throw the Storm Prediction Center outlook on here, and you could see that's why this area in orange has the higher risk for severe storms. That's why it's the enhanced, because this is the area, as I have the temperatures overlaid, that's becoming the warmest with the highest dew points. And that's what fuels severe storms. So, so anyway, the atmosphere is beginning to destabilize, which helps increase the risk for storms and strong storms. And that's happening more vigorously south and east of Raleigh. It's happening as well across the middle of the state, but not quite as vigorously. Okay, so that's why, again, we think the greatest risk for the most frequent severe storms and most intense severe storms should be across areas east and south of Raleigh. Okay, so that's the latest. That's your update at 10 o'clock. The timing, let me just show the latest in timing real quick. Bear with me here while I just shut everything down so I could switch to excuse me, so I could switch to the simulations. And this is a model simulation. This is updated from what I showed you earlier. And as we go forward in time, right here, this time frame is 11 a.m. That is noon, 1 p.m., 2 p.m., 3 p.m., 4 p.m. So 4 p.m., we see it beginning to move into the triad region, or moving into the triad region down toward Albemarle and Wadesboro. Okay, so again, that time frame right there is 4 p.m. Oops, sorry about that. Let me get centered back up. 5 p.m., 6 p.m., 7 p.m., 8 p.m., 9 p.m. Okay, so one more time. That right there is 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m., 6 p.m., 7 p.m., 8 p.m. Now, let me just back up and randomly stop it right here. Again, any of these cells will have the potential to produce damaging straight line wind gusts, 60 to 70 mile per hour wind gusts. So again, I'm backing up here. Anywhere along this line, there will be a potential for 60 to 70 mile per hour winds when it evolves. And we can't rule out isolated embedded tornadoes. Again, the areas with the best chance for those tornadoes will be areas south and east of Raleigh. Okay, so that's the way. And then one last thing I want to address real quick. We had a couple questions earlier about what about this activity? What about this activity that runs out ahead of the main line? Is that going to be, is that going to be worrisome or severe potential? And the expectation with that is, I don't want to say no, but I'm not as concerned about these isolated cells as I am this line right here. I'm most concerned about this line. I'm somewhat concerned about these individual cells, but not as much, okay? And we'll be able to, again, when I provide my hourly updates here on this webinar, we'll be able to kind of touch base on these little cells out ahead of everything, okay? So, and again, also keep in mind with it warming up, the risk for those winds, those background winds increasing will also be there. And we'll be seeing some gusty winds, even outside of thunderstorms, developing this afternoon, okay? So one last time on the simulation, this is 3 p.m., 4 p.m., 5 p.m., 6 p.m., 7 p.m., 8 p.m., 9 p.m., 10 p.m., and then 11 p.m., and just maybe a few straggler light showers behind it. Okay, so that's your 10 o'clock update.